Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics and waves from October-November 2020 paper 1. In today's class, our main focus will be on waves because waves are considered to be most difficult among students at ES level. So in today's class, we will discuss waves in detail so you can have clear understanding or at least you can have better understanding of this topic. Let's study together. Let's improve together. For question number 20, it is given to us a platform is suspended by 4 steel wires. Each wire is 5 meters long and has a diameter of 3.0 millimeters. Young's modulus of steel is given, that is equal to this. The wires obey Hooke's law when a load of mass 200 kilogram is placed on the platform. How far will the platform descend because of the extension of the wires? So simply in this case, we need to calculate extension of the wires. For this question, we have Young's modulus, diameter is given, length is given, and the mass is given. So we can calculate weight. We can answer this question using two different approaches. So let me explain you first of all which two approaches you can use for this problem. One way to answer this problem is you can take 4 rods together. If we take 4 rods together, they are supporting total mass that is equal to 200 kilograms. We can also take one rod because these rods are identical. So the extension in each rod is also the same. So we can also take one rod only. So the one rod is supporting 200 by 4 kgs. So we can simply say this one is equal to 50 kgs. So we have these two different approaches. In first approach, we are saying we have 4 rods and they are supporting 200 kgs. So here we have, so this is the sketch. We have 200 kgs. We need to find out extension in each rod. On the other hand, we can sketch like this. We have one rod and this rod is only supporting 50 kgs and we need to find out extension in this rod. Let's start with one rod. For one rod, we can write down Young's modulus. This is equal to stress over strain. Stress over strain. Stress is equal to F over A and strain is X over L. So we can rearrange, we can write down, in this case, we have F over X times A times L. Now, simply we need to plug in values. We need to calculate value of X. We can rearrange this. X will be equal to FL divided by E times A. So this method we are only using for one rod only. So the force on one rod will be equal to 50 times 9.81. Length of rod is given, that is 5.0. So we can write down this is equal to 5.0. And we have to divide this one by Young's modulus. Young's modulus is 2.1 times 10 to 11. And we need to multiply with cross-sectional area of one rod. We have diameter, so we can write down pi by 4 d squared. So we have d, that is 3 millimeters. So this is 10 to negative 3 square. If we solve this one, we can find out value of x. X in this case will be equal to 1.7 times 10 to negative 3 meters. So this is value of extension. So this is how we can calculate value of extension. On other hand, you can also use 4 rods together. 4 rods you can use together. So in that case, what you need to do is simply you have to multiply this one with 4 and cross-sectional area you also need to multiply with 4. So this 4 will be cancelled with this 4. So still you will get the same answer. So our answer for this question is this. This is the right answer. For question number 21, it is given to us a tensile force of 7.0 meganewtons is applied to a sample of steel. This causes the sample to extend by 5 mm in direction of force. The sample obey Hooke's law. We need to calculate what is the work done to extend the sample. First of all, you can imagine that we have a steel rod. So imagine that this one is the steel rod. This is hanging here. And then we attach a weight of 7 meganewtons at the end of this rod. And this rod extended by 5 mm. So here we have weight, this is equal to force, and this is 7.0 times 10 to 6 newtons. And extension in this rod is given. This one is the extension. So this is extension. And value of this delta x is given. That is equal to 5.0 mm. So we need to find out work done. For this question, it is given to us the sample obey Hooke's law. So simply we can sketch graph between force and extension. So we have force on y-axis and we can sketch extension on x-axis. If we sketch the graph between these two quantities, it has to be a straight line because this sample obey Hooke's law. We need to calculate work done. So it simply means we need to calculate area under this line. So in this case, area is equal to work done. So simply we can say area is equal to work done. And this work done is equal to area of triangle. 1/2 F times X means extension delta X. Now simply we need to plug in these values. So we have 1/2 and the force is given, that is equal to 7 meganewtons. So we can say 7.0 times 10 to 6. So this is 7 meganewtons and extension is 5 millimeters. So we can say 5 times 10 to -3 meters. If we solve this one, our final answer should be 17.5 times 10 to 3 joules. But answers are given in kilojoules, so we can convert this one into kilojoules. So this will be equal to 17.5 kilojoules. So the answer for this question is C. For question number 22, it is given to us we have two waves X and Y and they have the same frequency. The amplitude of wave X is 1.5 A0 and amplitude of wave Y is 2.5 A0. The waves meet at a point and superpose to form a resultant wave. For the resultant wave, we need to find the ratio between maximum possible intensity and minimum possible intensity. Maximum possible intensity we will get when waves interfere constructively. So we can simply say when constructive interference will take place, intensity will be maximum. Constructive interference. And intensity will be minimum when destructive interference will take place. Destructive interference. So very simple way to understand this one. Maximum and minimum intensity. Now we can draw two waves. First of all, we can draw wave X. So we will only draw one pulse. So it will be easy to see what is happening. Imagine that this is wave X. This is pulse of wave X. And this is moving to the right. Amplitude of this wave is given. So this is the amplitude. And this one is equal to 1.5 A0. We can also draw another wave Y. Let's say this is pulse of wave Y. And this wave Y, we can imagine that this is moving to the left. Amplitude of this wave is also given. Amplitude of this wave is AY, that is equal to 2.5 A0. Now let's try to understand when these interfere constructively. So what is the amplitude of resultant wave? So first of all, we will draw for constructive interference. Constructive interference. Constructive interference. So for constructive interference, we have wave X and we have wave Y. Y is moving to the left. So we have these two waves. So this one is X and this one is Y. At this point, they will interfere with each other. So when they will interfere constructively. So we will get a super crest. So we will get super crest like this. Means simply we need to add these two waves together. So this is the super crest we will get when these two waves will interfere. And the amplitude of this super crest will be equal to amplitude of X plus amplitude of Y. So the final value of amplitude we will get 2.5 A0 plus 1.5 A0, that will be equal to 4.0 A0. Now we can repeat the same process for destructive interference. Destructive interference. means when the waves cancel each other. In this case, we have wave X. Let's say this is the crest of wave X. This is moving to the right. So this one is wave X. This is moving to the right. And we have trough of wave Y that is moving to the left. So this is wave Y. Let's say they interfere at this point. So in this case, the amplitude of this one is negative. So this is negative 2.5 A naught. Then this one is 1.5 A naught. So when they will interfere at this point, they will cancel each other. So we will get minimum value of amplitude. So in this case, we have 2.5. So we can just subtract 2.5 A naught minus, we can take 1.5 A naught. So this one will be equal to A naught. We can clean little bit and we can redraw. So here, so this one is the resultant. So let me use different color and write on here. So this is over resultant wave and this is also resultant wave. This is amplitude of resultant wave and this is also amplitude of resultant wave. Now we need to understand the relationship between intensity and amplitude. Intensity is directly proportional to amplitude square. Or simply we can say intensity over A square, this is equal to constant. So we can write down this is equal to constant. For the maximum we can say I max over A max. We can say this one is A max. A max square has to be equal to I min. So I minimum divided by A minimum means this value A minimum. We can also write down here. So this one is A minimum and this one is A max. A max. So this is A minimum square. Now we need to rearrange this. So we can write down I max divided by I min. This will be equal to A max square divided by A min square. Now we can plug in values. A maximum is equal to 4 A naught and A min is A naught square of this. Now if we solve this one, we will get 4 by 1. In this case, this is 16. So we will get this is 4 square by 1 means we will get 16 by 1. A square will be cancelled with A square. So we left with 16 by 1. So the answer for this question is 16. So this square is very important. If you miss this one, maybe you will tick on C. So square is very important. We can also write down here this is 16 A square, A naught square, and this one is A naught square. So the A naught is cancelled with A naught. So the answer is D for this question. For question number 23, it is given to us the displacement time graph for an air particle in the path of a sound wave is shown. We need to find out which property of the sound wave must be increasing. So this is very important. But if you look at this given graph, you can see on y-axis we have displacement and on x-axis we have time. In this case, amplitude of the wave is not decreasing, means it's not changing. So simply we can say amplitude of wave is constant. But if you look at time period, so this is t1 we can say, and here time taken from here to here, this is t2. In this case, t2 is smaller than t1. It means that time period of the wave is decreasing. Time period of the wave is decreasing, but we need to find out which property is increasing. But if you look at the relationship between time period and frequency, time period is equal to 1 over frequency. If the time period is decreasing, it means that frequency must be increasing. We can also write down this one. Frequency is equal to 1 over t. If time period is decreasing, it means frequency is increasing. Let's try to understand a little bit more about this one. We have already discussed, in this case, frequency is increasing. As frequency is increasing, it means that frequency of source is changing. So we can say frequency of source is changing, or we can say frequency of source is increasing. It means source is sending waves with different frequencies, and the frequency of the sound waves is increasing. So source is sending sound waves every time, but with different frequencies, with increasing frequency. Now if you look at the speed of the wave, that is equal to v times f lambda. Speed of the wave, this depends on medium. Speed of a wave, it depends on medium. and it depends on type of wave. But in this case, we have sound wave, so we have the same type of wave and they are in the same medium. So it simply means that frequency, if this frequency is increasing but speed is the same, so the lambda of the waves, coming waves, has to decrease. So source is producing sound waves with different frequencies, means with increasing frequency. So the lambda of the coming waves has to decrease. So simply this is what you can understand from this one. I mean how this is produced. Question is asking us to find out which property of the sound must be increasing. Amplitude is not changing, but frequency is increasing. So this one is the right answer. Period is decreasing. So this is not right answer. If we assume in the same medium, so speed is constant. So this is also not correct option. So this is also not. So the answer for this question is A. For question number 24, it is given to us a sound wave is displayed on the screen of CRO as shown in this figure. This is a typical type of question. Every year you will see one question about CRO. So the understanding of CRO is very important for paper 1. For this question, it is also given to us that time base of the CRO is set at 2.5 milliseconds per centimeter. We need to find out what is frequency of the sound wave. If you look at time period of this, in this case, you can see this is one wave from here to here. So this one is one wave. So this is half time period and this is one time period. And if you look at this one, in this case, we have 4 centimeters. Means we have 4 small boxes. We have 4 small boxes, mean we have 4 centimeters. In this case, we can say time period is equal to 4 small boxes, and this is equal to 4 centimeters. We need to find out time period. It is given to us that 1 centimeter is equal to 2.5 milliseconds. We have 4 centimeters. We need to find time period. So we have to multiply this one with 2.5 milliseconds per centimeters. So we can cancel centimeter with centimeter. So in this case, we can find out value of time period. That is equal to 4 times 2.5 milliseconds. We need to find the frequency of this wave. So frequency will be equal to 1 over t. So simply we can write down in this case 1 over 4 times 2.5 milliseconds. So this is 10 to negative 3. Now if we solve this one, frequency will be equal to 100 hertz, and that is value of frequency. So simply we can say in this case frequency is equal to 100 hertz. So this one is the right answer. So this is how you can approach this type of problems. For question number 25, it is given to us the horn of a train emits sound of frequency f1. While the horn is sounding, the train moves directly towards a stationary person. The speed of the train is 0.20 v. V is the speed of sound. The frequency of the sound heard by the person is f2. We need to find out what is the ratio of f1 over f2. First of all, let's sketch this one. So this one is the train. For this train, we have the speed of this train. This train is moving with speed 0.20 v. And the frequency produced by this train is f1. And this is equal to frequency of the source. Observer is standing in front of this train and observer is at rest. We can say speed of observer is equal to 0. For this question, it is also given to us the frequency of the sound heard by this observer is f2. So we can say this is frequency of sound observed by this observer. Now simply we need to use Doppler effect. In this case, source is approaching. So we have to use Doppler effect when source is approaching. So this is the point you need to understand. In this case, is the source is approaching or is the source is moving away? In this case, source is approaching. As the source is approaching, we can write down observed frequency. This one will be equal to speed of the wave over speed of the wave minus speed of the source times frequency of the source. Now we can rearrange this one. We can write down F naught by Fs. This will be equal to V over V minus Vs. Now simply we need to plug in values. F naught, observed frequency, F naught, this is equal to F2, and Fs, this is equal to F1. And this is equal to V over speed of the wave is V. So we can say this is V. V over V minus speed of the source is 0.20 V. Now just we need to simplify. In this case we can write down F2 over F1. This is equal to V over, we can take common V from here, so this is 1 minus 0.20. So simply we can cancel this V with this V. So we left with 1 over 0.80. We need to find out F1 by F2. So this is F2 by F1. So we can write down F1 over F2. This will be equal to 0.80 divided by 1. So this is our final answer. This is what question was asking us to calculate. So the answer for this question is 8. For this question, you have to be careful. It's little bit tricky one. Maybe some student they will just tick this, but this is wrong option. This is F2 over F1. Question is asking us to calculate F1 over F2. So just be careful with this. For question number 26, it is given to us two satellites are in orbit around the Earth at a constant distance of 100 kilometers apart from each other. Satellite X transmits a microwave pulse towards satellite Y. The pulse takes time t to reach Y. Satellite Y then transmits a pulse of visible light towards satellite X. What is the time taken for the pulse of light to reach X? So first of all, simply we can imagine that there are two satellites. So we can say this is satellite X and we have an other satellite here at a distance of 100 kilometers. Distance between these two satellites is given. Distance is equal to 100 kilometers. We can say D is the distance. Satellite X transmit microwaves. So this transmits microwaves. So we can write down here satellite X transmits microwaves. And the time taken for microwaves to reach Y is T. Time taken is T, we can say, for microwaves to travel from X to Y. We need to find out the time taken by visible light that is transmitted by satellite Y, visible light. So simply we can write down here visible light. We need to find out how long this will take, means the time taken by visible light to reach X. So this time we need to find out. Let's try to understand about speed of wave. Speed of wave, it depends on two factors. One, it depends on medium. If the medium is different, speed of the wave will be different. And speed of the wave also depends on type of wave. Type of wave means different waves in the same medium, the speed is different. If you look at these two waves, means the microwaves and visible light, they belong to electromagnetic waves. It means they belong to same type of waves because this is electromagnetic wave and visible light also belongs to electromagnetic waves. So they are same type of waves. As they are same type of wave and they are in the same medium, it means the speed of the visible light, we can say the speed of visible light is equal to speed of microwaves. Because they are same type of waves, they are electromagnetic waves and they are in the same medium, so they have the same speed. Now if you look at distance, distance is equal to speed times time. Speed times time. Now from here we can say time will be equal to distance over v. Distance is the same, so if the speed is also the same, it means time taken is the same. So the answer for this question is T. So the visible light also will take time capital T to travel from Y to X. For question number 27, it is given to us a stationary wave is formed on a stretched string. The diagram illustrates the string at an instant of time when the displacement of the string is at its maximum. The frequency of the wave is given, that is equal to 250 Hz. Point P on the string has a vertical displacement of negative 1.0 mm. What will be the vertical displacement of the point P after a time of 5.0 milliseconds? How we can approach this problem? So the first thing you need to understand, in this case, it is given to us this point is at the lowest point, and the amplitude of this one is equal to 1.0 mm, and frequency of this wave is given. So we have the frequency, so we can start from frequency. Frequency in this case is equal to 250 Hertz. So we can calculate time period of the wave. Time period will be equal to 1 over frequency. So we have 1 over 250 Hertz. So if we calculate value of time period will be equal to 4 milliseconds. 4 milliseconds means that wave will complete one cycle and time taken is equal to 4 milliseconds. Mean if this point start from here and when it come back to this point, time taken will be equal to 4 milliseconds. Now let's try to do this question step by step. We have to find out displacement after a time of 5.0 milliseconds. So if this particle move from lowest point to this point, time taken is equal to 1 milliseconds. And then when it goes to the highest position, again it will take 1 millisecond. And then it will start coming down. So when it will come from this highest to the equilibrium, it will take another 1 millisecond. And then when it will move from equilibrium to the lowest point, means to this point again, it will take another 1 millisecond. So 4 milliseconds have passed. 4 milliseconds. We still have 1 more millisecond. So for that one, we will be using different color. So this will go up again. So it will take again 1 millisecond to move from the lowest point to equilibrium. So it will take 1 more millisecond. So after 5 milliseconds, this particle, it will be at this point. The vertical displacement of point P will be equal to 0 because this is at rest position. So vertical displacement of this one is equal to 0. You can also understand this one. Particles start from this point, it will go up, and when it come back to this point, it will take 4 milliseconds. And then it will go up. It will reach this point. It will take 1 more millisecond. So the vertical displacement at this point will be equal to 0. So the answer is B. For question number 28, we need to find out what is meant by diffraction. If you look at option A, it is given to us the change in observed frequency when a source moves relative to an observer. And this is Doppler effect, means the change in observed frequency. So this is Doppler effect. This is not diffraction. The formation of nodes and antinodes by two progressive waves traveling in opposite directions. And this is telling us about standing waves. So this is description of standing waves. If you look at option C, it is given to us the spreading of a wave around the edge of an obstacle, and this is diffraction. So this one is diffraction. So our answer for this question is C. So C is the right answer. If you look at option D, it is given to us the superposition of two waves when they meet. This is about interference of waves. So we can say this is about interference. So the answer for this question is C. For question number 29, it is given to us in a dark room, a small source of red light illuminates two slits, and the distance between two slits is given, that is equal to 0.75 mm. A few meters beyond the slits, the light falls on a screen, producing a series of equally spaced bright lines. We need to find out which change would cause the distance between the bright lines on the screen to reduce. So first thing we need to understand is this question is about Young's double slit, or is it about about diffraction grating. If you look at statement of this question, it is given to us two slits. So it is about Young's double slit experiment. So in this case, we have slits, so we can simply draw here. We have two slits, and the source of light, we can imagine that the source of light is here. So this one is source of light. We can say this is S, and screen is placed here. So this one is screen. It is given to us the distance between screen is few meters beyond. A few meters beyond the slits, light falls. So distance between slits and the screen, few meters. But the distance between these two slits is given. We can say that distance is equal to d. Let's say this distance is small, and this is equal to 0.75 mm. This is source of red light, so we can also say this is red light. We need to find out when the separation between the fringes, so these are the fringes, so these are bright fringes. So simply we can draw these are bright fringes, and the distance between these fringes, two consecutive bright fringes, let's say that distance is equal to x, and the distance between slits and screen, let's say, is equal to capital T. Now let's try to write down formula for Young's double slit experiment, and formula is dx is equal to lambda times d. In some books they use a instead of d. So simply you need to understand a or d. This is the distance between the slits, or you can say slit separation. If we rearrange this one, we can write down x is equal to lambda times capital D divided by d. Now if you look at option A, it is given to us change the source for one emitting blue light. Lambda of the blue light is smaller than lambda of red light, so we can write down here red light. Now if lambda go down, means lambda decrease, it means x will decrease. If we keep d same and capital D same, so it means x will decrease, and this is what we need to find out. So the answer for this question is A. Now let's move on to option B now. For option B, it is given to us reduce the distance between the source and the slits, means reduce this distance. Let's say this distance is S1. Question is asking us to reduce this one. If we reduce this one, there will be no effect because there is no distance between source and the slits in this equation, so it means no effect. If we change the distance between source and the slits, it will have no effect on fringe spacing. X is fringe spacing, so simply we can also write down here x is fringe spacing, mean the separation between bright fringes, it will not change. But if we reduce this distance or we increase this distance, mean s, if we increase or if we decrease, it will have effect on brightness of bright fringes. So this is also we need to understand. Now if we go to part C, it is given to us reduce the distance between the slits to 0.5 mm. Now this is telling us we reduce d. If we reduce d, it means x will increase, so this is not answer because we need to find out when x will decrease, mean x will be reduced. So that's reason C is not right answer. Reduce the intensity of the light source. It will affect the brightness of bright fringes, but it will not affect fringe spacing. So D is also not possible answer. B is also wrong. So the answer for this question is A. For question number 30, it is given to us light of wavelength 5.3 times 10 to negative 7 meter is incident normally on a diffraction grating. The first order maximum is observed at an angle of 15.4 degrees to direction of the incident light. We need to find out what is the angle between the first order and the second order diffraction maximum. So first thing we need to understand, this question is about diffraction grating. So we can draw diffraction grating here. So this is diffraction grating, and we can imagine this is the light. So light is coming from here, and we have screening here, and at the center we have center bright fringe. So n for this one is equal to 0, and the first fringe we observe here, so this this one is the first, and we have the second one. Observe here, this is n is equal to 1. This one we can say n is equal to 2. For this question, it is given to us the angle of first order maximum. This angle is given, so we can say this is theta 1. Value of this one is given, that is equal to 15.4 degrees. Question is asking us to find out angle between these two, means this angle question is asking us to find. So this is what we need to find. First of all, we can find out angle of second order, means we can find angle of second order maxima. We can find out this angle theta 2. Then we can find out the difference between these two, that will be equal to theta. So first of all, we can say theta, or you can say delta theta. This will be equal to theta 2 minus theta 1. Second order and first order. Now first of all, we need to find out theta 2. We can write down for n is equal to 1. For n is equal to 1, we have d sine theta, means this is equation for diffraction grating. D sine theta is equal to n times lambda, but n is equal to 1, so we can say this is d sine theta, and this one is equal to lambda. We can say this is equation 1. We can also write down for second order, means when n is equal to 2, we can write down d sine of theta. This is equal to 2 times lambda, and this is theta 1 and this is 2. So we can say this is over second equation, but value of theta 1 is given, so we can rewrite here. So we can write down d sine of 15.4 degrees. This is equal to lambda. We can say this is over third equation. Now if we divide 2 by 3, we can calculate value of theta. So in this case, we can write down d sine theta 2. This is equal to 2 times lambda, and this is divided by d sine of 15.4 degrees, and this is equal to lambda. Now we can cancel this lambda with lambda, and d we can cancel with d. We need to find out theta 2, so we can say sine theta 2 in this case will be equal to 2 times sine of 15.4 degrees. 15.4 degrees. From here we can find out value of theta 2. This one will be equal to sine inverse of 2 sine of 15.4 degrees. Now if we solve this one, we will get value of theta for the second order, and this one will be equal to 32.1 degrees. So we have value of theta 2. So this is theta 2. We need to find out the difference between these two. So we can write out here 32.1 minus we have 15.4 degrees. If we solve this, our final answer will be 16.7 degrees. So this is our final answer, and this is the angle between first order and second order, means this angle. We have found value of this angle. So the answer for this question is C, 16.7 degrees.